Hello, this is Bai. Today we are going to talk about a specific chapter in AP Calculus AB. So the chapter is about integration. So when we talk about integration, it's actually the antiderivative of a function. So it's going to be something like this. So we have to write down the notation integral, and then the function should be written at the middle, and then dx. So when we look at a notation like this, we have to know we have to do the opposite way of the differentiation, that is the antiderivative, okay? So before we talking about the important formula about how to integrate, we have to go through some important basic formulas about differentiation. So let's take a look at the first one. So x to the power of n derivative is going to be n should be dragged to the front times x to the power of n minus 1. So this is what we call the power rule. Second, sine x derivative is going to be cosine x, and then cosine x derivative is going to be negative sine x, and then tangent x derivative is going to be sec x squared. So sec x squared is the same as sec x squared is just like this. It's just like a special written form, okay? So we have to keep in mind. And then for cot x derivative is going to be negative cosec x squared, okay? And then for e to the power of x, the derivative is going to be e to the power of x, it just itself. And then for natural log of x, the derivative of that is going to be 1 over x. And then a to the power of x. So a is a constant, is a number, is not e, because e is a special case, that is the natural number. It's going to be a number like this. But if it is a to the power of x, it's going to be like a very common number, right? So it's going to be a to the power of x. We does not change it, but we have to times natural log of a before that. So that is the formula for this. And then for arc sine x derivative is going to be 1 over the square root of 1 minus x squared. And then for arc tangent x derivative is going to be 1 over 1 plus x squared. So these are very important formulas about how to differentiate, okay? So now let's talk about how to anti-differentiate. So when you look at something like this, so we have to think about which function is going to have the derivative like this, right? So we have to think about that in the opposite way. So for the first one, if you want to have a derivative like x to the power of n, so the function before differentiation should be x to the power of n plus 1, right? Because x to the power of n is the expression after using the power rule, right? And then x to the power of x plus 1. And then there must be a fraction before that to cancel out the n plus 1 when you want to do the power rule, right? So there must be 1 over n plus 1 before that. So that is the formula for this. And then do not forget to write down c after that. And then for the second one, because we know the derivative of e to the power of x is itself, so integration is going to be the same thing. So the integration of e to the power of x is going to be itself, but you do not forget to write down c after that, okay? And then for integration of sine x is going to be negative cosine x plus c, right? And then for the cosec x squared derivative, for the cosec x squared integration, and then we just write down negative cot x plus c, that's it, okay? So that is the very typical formula for arc sine, right? So it's going to be arc sine x plus c, okay? And the next one, for the integration of a to the power of x is going to be like a to the power of x itself, but do not forget to write down the fraction before that to cancel out the natural log of a. So that is going to be 1 over natural log of a, and then do not forget to write down c here. And then for the integration of x to the power of negative 1 is going to be the integration of 1 over x dx. So that is the natural log of the absolute value of x plus c. And then the integration of cosine x is going to be sine x plus c. And then here, the sec x squared, the integration of that is going to be tangent x plus c. And then for 1 plus, is 1 over 1 plus x squared is going to be arc tangent x plus c. So these are very important formula we have to keep in mind when we do integration. Okay. So here we have a list we have to keep in mind. And then besides this, we have to know the basic rules about how to like a plus or minus, or when we want to multiply a specific constant, we have to know if there is a scale factor just to try to multiply a function, we can directly drag the k constant out. So it's going to be k times the integration of the function itself. And when you meet something like this, like there's a plus or minus relationship between different functions, and then we can just separate them out. And we keep the plus or minus relationship at the middle. We can just integrate the different functions separately, okay? So now let's do some exercise. So the first one is about integration about t, in terms of t, right? So the function is going to be 2 to the power of t plus e to the power of pi. We have to be really careful here. E is a natural number, is a constant. Pi is also a constant. So e to the power of pi is going to be a constant. So when you try to integrate, do not just treat it as a like an expression with variable, right? So we have to be careful about that. And then, so for here, if you want to try to integrate, it's going to be e to the power of pi x, right? And then, here is the independent variable is t, right? So we just write down t here. And then 2 to the power of t is going to be 2 to the power of t itself. Do not forget to write down 1 over natural log of 2 before that to cancel out. And then plus this, and then do not forget to plus c, okay? So let's see, when you go through different options, B would be the good choice, okay? And then today we are going to learn something special about substitution method. So substitution method is a way to help us to simplify a complicated function into an easy form. It's better for us to understand. So let me give you an example to try to understand the way how to use that by using an example. So for example, when you want to use a substitution method, there must be a special pattern showing in front of you, like integration, like dx or dt, whatever. And then at the middle, you would have to find there is an original function at the middle, and then there is a derivative of that, multiplying that or dividing that. So they must have relationship like this. So when you meet a pattern like this, you have to set u is equal to the original function, okay? So let's take a look at this question. So here is the thing. For this question, we have to use a u is equal to 2t squared minus 1. We have to set it as u. We have to treat 2t squared minus 1 as the original function, because when you try to differentiate that, for example, du over dt is going to be 4t, right? So 4t is 4 times t, right? So t can be replaced easily. So that's why we have to set u is equal to 2t squared minus 1, right? So, and then du over dt is 4t, right? And then du is equal to 4t dt. And then if I were you, I would divide it by 4 on both sides. So it's going to be du over 4 is equal to t times the dt. Why should I do this? Because there is a t times the dt here, and then t times the dt here, right? So this you can treat as a group to be replaced with the du over 4. So now it's time to replace, to substitute. So the original function integration t over the square root of 2t squared minus 1 dt can be written as integration 1 over the square root of 2t squared minus 1 times t times dt. So here is the thing. This part can be replaced with u, right? And then integration 1 over the square root of u. And then this part can be replaced with 1 over 4 du, right? So a very complicated form right now is converted into something simpler, easier to understand, right? So we can reorganize the structure. So it's going to be equal to 1 over 4 can be dragged out, right? Integration 1 over the square root of u can be written in another form, that is a u to the power of negative 1 over 2, and then du. So we can try to use the power rule to anti-differentiate that, right? So it's going to be 1 over 4. If you anti-differentiate that, so the exponent must be 1/2, right? And then there must be something before that to cancel that, to cancel the 1 over 2 if you want to apply the power rule. So there's a 2 before that, and then plus c. And then we just simplify that, 1 over 2 u to the power of 1/2 plus c. And then now it's time to substitute the original expression back into this equation. So it's going to be 1 over 2t squared minus 1 to the power of 1/2 plus c. So if you want to use the square root to represent that, is also a good thing. So 1 over 2, the square root of 2t squared minus 1 plus c. So D is the correct option. Understand this problem? All right, so here is another thing. When you want to try to integrate this, is more complicated. So let's try to do this. So integration 1 over the square root of 4 minus y squared dy. So when you look at it, like the function at the middle, you would notice that there's no like original function and the derivative multiplying or dividing together. No, it's not the case to use the substitution method, right? But it's really similar to a formula. So that is the integration 1 over the square root of 1 minus x squared dx is equal to arc sine x plus c, right? So this is something we learned before. That is the formula we have to keep in mind. But the problem is that the number under the square root is 1 instead of 4. So what we should do is to separate the square root into two parts multiplying together, right? So here's the thing. It's going to be integration 1 over the square root of 4 times the square root of something. You can have a guess. Okay, so here is 1 minus y squared over 4, right? Because when you combine them together, is the same as this. So, and then dy should be written here, and then the square root of 4 is actually 2, right? So we just write down 2 here, and then 1 over 2 can be dragged outside. So it's going to be 1/2 integration 1 over the square root of 1 minus y squared over 4 can be written as y over 2 square, right? And then dy. So this structure is pretty much similar to this, but there's a little bit different that because that is the x here, that is a y over 2 here. So if you want to try to use the substitution method to make it easier, is good. So right now we can use u is equal to y over 2. So du over dy is going to be 1/2, and then du 2 du cross multiply, right? 2 du is equal to dy, and then we can try to substitute the things back to make the expression easier to understand. So the expression is going to be 1/2 integration 1 over the square root of 1 minus u squared, because we use u to substitute y over 2, right? And then du is actually 2, dy is actually 2 du, right? So we times 2 times du, and then 2 and 1/2 can be cancelled out. So is going to be integration 1 over the square root of 1 minus u squared du. So it's going to be arc sine u plus c, right? So after integration, it's time to substitute the original function back. So it's going to be arc sine y over 2, right? And then plus c. So arc sine is actually the same as the inverse function of the sine. So they are actually the same thing. So that's why for this question, we choose C. Okay? May I make it clear? All right, so this is all for our today's lesson. If you have any question, you can ask me later, or we can study together. Hope to see you soon. Bye-bye.